It's Angie over at Angie's Beyond the Lecture. And have you, as a chemistry student, have you ever run into problems where they want you to determine how many ions are in a particular compound? And if you struggle with cases where they have multiple ions. So here are some examples. The point of this video is just to take you through actually one main example. You have a couple additional examples to try on your own in this particular review sheet. And of course, this review sheet is available on my website with the answers at the end. So if you want to check your work there, go ahead and do it. But again, anything I have in my videos can be found out on my website, including material that I go through on my videos. So to start, of course, we're going to use Avogadro's number whenever we're dealing with particles, atoms, item counts in the chemistry world. We're going to be dealing with Avogadro's number, and we know by definition 1 mole of any substance has the 6.022 times 10 to the 23 particles. And they want you, in this particular case, these questions are worded in such that they want you to take it a step further and determine the number of ions in an ionic compound. All right, so magnesium chloride, perfect example. We have 1 magnesium cation, 2 chloride anions. And the point here is that you just need to add this extra conversion factor. And that's what tends to trip up students. I remember this distinctly in my chemistry course I took quite some time ago, and it gave me a little bit of trouble, as well as other students. Now, when we look at our example here, we'll just use magnesium chloride. We'll keep going down here. And the question is, we have 4 moles of magnesium chloride. How many specifically of those chloride ions are present? So again, step 1, you just identify what we're given, what's needed. We have 4 moles of magnesium chloride. Avogadro's number is a given. And now we have an extra ratio to apply here. So for every 1 molecule of that magnesium chloride, we're going to generate 2 of those chloride ions. And of course, they want the chloride ions as your final answer. Now, our first step would be to take magnesium chloride, and we have 4 moles. Got to add that up front. So for every 1 mole of anything, we know we have in this case, we have MgCl2 molecules. And of course, we sometimes call these formula units, and we'll do that here. 4 times Avogadro's number. And always cancel your units. Beautiful. So we have 2.4 times 10 to the 24th MgCl2. And we're not done yet because we just know number of molecules, right? We only know our number of molecules. We need to break it down further. So we're going to take it one more step here, and we'll just move our answer down to the next step. We're going to say 2.4 times 10 to the 24 MgCl2 molecules. And I know for every 1 molecule, I actually have 2 chloride ions. More specifically, ions or anions. And once we do, again, molecule of MgCl2. There we go. There we go. So our molecules have canceled, and we're just taking our previous answer times 2. So in the end, we generate 4.8 times 10 to the 24 Cl ions. To confirm the final answer here, I took the 2.4 times 10 to the 24 magnesium chloride molecules and multiplied it by 2 using our dimensional analysis here. And final answer, that would be that. 4.8 times 10 to the 24. All right, so, and actually I'll use this space to demonstrate like a simplified model that we're looking at. So for instance, if we were asked I have 10 cars. How many tires do I have, right? That's sort of what they're asking here in this problem. If we have 10 cars, how many tires do we have? Well, I can't say 10 cars, right? I have 4 tires for every one car. So in the end, I have 40 tires. Okay. I'm just applying that ratio right there to determine number of tires. I actually split apart. I actually split apart 2 pieces. So we're just breaking it apart and applying that conversion factor. So again, make sure and double check you apply Avogadro's number and you have the correct ratio of ions per molecule. So that's really just making sure you have the correct formula. Okay. If you have the wrong formula based on the ionic compound given, if they give you just the name, of course, you have to determine the formula. If that's wrong, the entire answer is wrong. Now, some additional tips here. You need to apply that conversion factor. We can call it an ion ratio. Same thing. Double check your units. Again, dimensional analysis, just make sure your units cancel out and you're left with the quantity on top. You're left with the correct unit on top when you do your final answer. And yeah, the formula the subscript will tell you how many ions per molecule you have there. So additional practice here. Go ahead and work through that if you have the time and want to do that additional practice. And I'll link the additional video I'm putting out on just general conversion. So if you're a newer chemistry student or it's been a while since you've done some mathing, that'll be definitely an appropriate video to watch and brush up on your conversion. So thanks for joining me again. Have a great day. Hit like and subscribe if you'd like to be notified on new content as it rolls out. Thanks again.